Welcome back to the VTC course on Wireshark. My name is Jamie Oates and I am your host during this training. In the previous videos, we began with the OSI model, finishing with Layer 3, the network layer, in the previous video. Layer 4 is the transport layer. It is responsible for transporting the data from one node to another. It provides transparent data transfer between nodes and manages the end-to-end flow control, error detection, and error recovery. The transport layer protocols initiate contact between specific ports on different computers and set up a virtual circuit. The transport protocols on each host computer verify that the application sending the data is authorized to access the network and that both ends are ready to initiate the data transfer. This type of synchronization ensures that data is sent and received in an orderly fashion. When this synchronization is complete, the data is sent. As this data is being transmitted, the transport protocol on both nodes monitor the data flow and watches for data transfer errors. If errors are detected, the transport protocol provides additional error recovery. As you can see, the functions performed by the transport layer are very important to network communication. Just as the data link layer provides lower level reliability and connection-oriented or connectionless communications, the transport layer does the same thing but at a higher level. The two protocols most commonly associated with the transport layer are the Transmission Control Protocol, or TCP, which is connection-oriented, and the User Datagram Protocol, UDP, which is connectionless. The transport layer also manages the logical addressing of ports. We need to think of a port as an apartment number within a high-rise building. The port number defines exactly where the data should go or enter. Take port 80 as an example, which is used by TCP and HTTP traffic. HTTP being web traffic. Each website you view on the internet is transmitted over port 80. A computer may have multiple network applications, all running at the same time. Your web browser, Internet Explorer, Safari, or Firefox, each sending requests to a web server for a web page. Your email client, sending and receiving emails, and maybe even a file transfer program, uploading or downloading data from an FTP server. The mechanism for determining which incoming data packets belong to which application is the primary function of port numbers. By using ports, we are able to establish multiple connections, all at the same time with multiple applications. Each application is assigned a particular or designated port number. This ensures that data assigned to a specific application, such as email, arrives to the email application and not your web browser. Port numbers are used by the TCP and UDP protocols only. The transport layer also deals with name resolution. A website URL will be the best example of this. Instead of entering the IP address for the website, we are able to type a more friendly address, such as www.google.com, instead of 20.14.6. You get the idea. But computers only translate and communicate via numbers, so there must be a way to match numbers with numerical addresses. For this we have name resolution methods, such as the DNS, which solves this type of problem. In the next video, we will take a look at the session layer, which is layer 5 of the OSI model.